Dear viewers, we are learning to determine the association between two variables. And to determine the association or to check the association between two variables, we calculate correlation coefficients. So there are two options that we can either calculate Pearson Correlation Coefficient or Spearman Correlation Coefficient. These correlations are used to check the association between two variables, as I mentioned earlier, whether there exists association between two variables, either positive or negative. So we will use correlation coefficients. Before, as I told you, that we have two options, either Spearman correlation and Spearman correlation. Before using that, we need to know that what kind of data we have, how those two variables has been measured. If both variables are measured on a ratio and interval level data, then and we want to examine the association between the two variables, then we need to use Pearson correlation coefficient. And if both variables are measured on ordinal level data, so then we will use Spearman correlation coefficient. We will learn that how we can calculate these correlations in SPSS. Keep in mind one thing, correlation between two variables ranges from -1 to +1, and -1 means perfect negative correlation between the variables, and +1 means perfect positive correlation between the variables. So let's discuss an example. So we have items regarding customer satisfaction level with the taste of food, ingredient of food, freshness, temperature, and quantity of food. Let's check whether there exists a correlation between these variables. And keep in mind, these are scale variables. As you can see that they have been measured on strongly disagree to strongly agree, and this is the scale. It means they have been measured on 5-point Likert scale. So because these are scale variable, these items have been measured on scale variables. So therefore, we will use if we want to check the association between these scale variables, so we will use Pearson correlation coefficient. How we can calculate? So go to analyze, then correlation, then bivariate. So this is the test variable box. So these are the list of variables that we have included in our data set. Now we need to select the variables and put them into the test variable box. So like these are the variable which we are using to check the association between the variables. So in other words, we want to check the association between these variables. So here you can see Pearson correlation two-tailed and flag significant correlations. So it's mean if there exists a significant correlation between the variables, so then a star X sign will be mentioned on that. So let's say okay. So this is the output. So you can say this is Pearson correlation. Sample size was 76. And you can see this is the we have one correlation between one. It's in perfect correlation. So basically, correlation between the same variable. I'm satisfied with the taste of food. This is also a taste of food. So it means correlation between taste of food is perfect, positive correlation. So actually, there are some correlation above 1 values and some correlations are below the 1 value. So these correlations are correlation above 1 correlation 1 are the mirror image of correlation mentioned below this diagonal cell. So therefore, these are the same correlations. So we can either interpret the correlation above 1 or we can or correlation below 1. So let's interpret the correlation below 1. So the first thing, we need to interpret those correlation which carries direct signs. So this one's positive 3.59. This is minus 5233 and 0.348. These are positive signs. This is again positive 274 mean. Direct 2 means at the bottom of this table you can see it is significant at 0.01%, and this is significant at 0.05. It's been 5%. Direct 1 means significant at 5%, and direct 2 means significant at 1%. And now this is significant. It's mean correlations carrying direct signs, either one direct or two direct, so they are significant. Now we need to interpret whether this is a negative association between the two variables or positive. So this negative sign reflects that there is a negative association between taste of food and ingredients of food. This is insignificant association between taste of food and freshness of food. Again, insignificant relationship between taste of food and temperature of food. Again, significant but negative association between taste of food and quantity of food. Then there is a positive association between ingredients and freshness of food. Then again positive association between temperature of food and quantity of food. It means values carrying direct signs, so they are significant. So their negative or positive sign will tell us whether there is a positive association between the two variables, or a negative association between the two variables. So we learn to interpret this Pearson Correlation Coefficient. Keep in mind one thing, this Pearson Correlation Coefficient has one assumption, and this assumption must be satisfied before interpreting correlation coefficients. Pearson Correlation Coefficient assumes that both the variables should be normally distributed. We have a separate video that how we can calculate, check the normality of a variable. So you can watch that video. But in order to check the association, normality, so you need to watch another video. So before calculating Pearson correlation, we need to examine the normality of both variables. If both variables are measured on a ratio or interval scale, and both variables are normally distributed, it means then we can calculate Pearson Correlation Coefficient. If variables are normally distributed, if variables are not normally distributed, but both are measured on ratio and interval scale, so then we will calculate Spearman Correlation Coefficient. So in case of violation of normality of scale variables, we will use Spearman correlation. It means Spearman correlation can be used in two cases. One, if data is measured on ordinal scale, then Spearman correlation coefficient will be calculated. If data is measured on a ratio and interval scale, but the data is not normally distributed, even then we will use Spearman Correlation Coefficient. So you need to keep in mind this point. So let's examine another data. Let's check the association between two ordinal variables. So first one, I'm taking family size, like how many family members we have in the family, and then how much do they spend in order to buy the vegetables. So how much do they spend on vegetables in 1 week? So we have measured on a scale from 1 to 4, and 1 was less than 500 per week, and then 2 was 500 to 1000 rupees, and 3 was 100 to 1000 to 2000, and 4 was more than 2000 per week. So it means it was an ordinal variable. So similarly, a number of family members less than 5%, 6 to 10%, 9 to 11, and more than 11%. So it means more the family member we have, the more we're going to be spending on vegetables. So let's check because both are ordinal variables in this case, and we want to examine the association between these two variables. So we will use Spearman correlation coefficient. So how we will do it? Analyze, compare means, correlation, bivariate, and now we need to select family members with their or how many family members we have, and then how much do they spend. So these two variables has been selected. So you can see this is Spearman correlation. So we are not using Pearson, and again we will say okay, select flag significant correlations. So yes, you can see. It is insignificant relationships. So it's a significance level is 0.05 and this correlation is 192, but it is not significant correlation. So now it means now we check the association between two ordinal variables. So let's conclude that if we have if variables are measured on ratio and interval level data, we will use Spearman correlation to measure the association between the two variables. And if the data is measured on ordinal level data, then we will use Spearman correlation to check the association between those variables. Thirdly, if data is measured on ratio and interval scale, but both variables are not normally distributed, even then we will use Spearman correlation coefficient. Fine. Thank you very much.